All right, let's just jump right in. For decades, our search for aliens has been focused on planets that look a lot like Earth, orbiting stars that look a lot like our sun. But what if we've been looking in completely the wrong place? It's a huge question, really. Is Earth some kind of one in a trillion miracle? Or is life actually common, but just different? What if the most common home for life in the universe isn't a sunny blue world at all, but a planet trapped in a permanent alien twilight? So to really get this, we gotta start with the stars themselves. Forget about stars like our sun for a minute. The universe is absolutely dominated by one type of star. I mean, look at this chart. Red dwarfs make up a whopping 78% of all the stars in our corner of the galaxy. They are, by a huge margin, the most common game in town. And that brings up a really fascinating puzzle, right? If these stars are literally everywhere and they live for trillions of years, I mean, way, way longer than our sun, you'd think they would be the absolute best places to find life. So why are we here, orbiting a relatively rare yellow star? This question is so big, astronomers actually have a name for it. It's called the red sky paradox. And on paper, these red dwarf systems seem like the perfect little incubators for life. But as we're about to find out, there's a pretty harsh reality that comes with living so close to a small, dim star. Let's just run through the checklist of why they seem so perfect. First, like we said, there are just so many of them. That's a numbers game that's heavily stacked in favor of life. Second, they are insanely long-lived, giving evolution trillions of years to work its magic compared to our sun's measly 10 billion-year lifespan. And third, they're super stable, providing a nice, consistent climate for ages. So what's the problem? What gives? Well, the problem, it all comes down to one thing: proximity. To stay warm enough to have liquid water, a planet has to orbit incredibly close to its dim little red dwarf star. And that closeness creates a world of brutal, absolutely unforgiving extremes, starting with something called tidal locking. So what is a tidally locked planet? Well, think about our moon and the Earth. The moon always shows us the same face, right? It's just like that. But for these planets, it means one entire hemisphere is trapped in an endless, scorching day, while the other side is frozen solid in a permanent, frigid note. There's no day-night cycle like we have, ever. As UC Irvine researcher Ana Lobo puts it, the conditions are just stark. The day side is a baked desert, hot enough to boil away any chance for life. The night side is a complete ice-locked wasteland, a world of glaciers that never, ever see the sun. Yeah, neither side sounds very inviting. And just when you thought it couldn't get any worse, there's another major threat. Red dwarfs, especially when they're young, are famous for their violent tempers. They erupt with these incredibly powerful stellar flares, blasting their nearby planets with lethal doses of radiation that could just strip away their atmospheres and sterilize their surfaces. So the situation is looking pretty bleak. You've got a scorched day side, a frozen night side, and you're getting hit with constant radiation baths. But, and this is a big but, a groundbreaking new climate model from researchers at UC Irvine suggests we might be overlooking the one place where life could actually hold on. Not on either side, but right in the middle. So, to recap, we're left with this planet of two completely uninhabitable halves. One is a furnace, the other is a deep freeze. But what if the answer isn't about choosing a side? What if the key to life on these worlds is right there on the border, on the very edge of light and shadow? This right here is the Terminator Zone. It's this band of perpetual twilight that goes all the way around the planet, separating day from night. And in this narrow sliver of eternal sunset or sunrise, the climate models show that temperatures could be just right for liquid water to exist on the surface. We may have found a loophole in the rules of habitability. This idea just opens up this wild new possibility for what a habitable world could look like. But let's just imagine for a second. What would it actually be like to live in this strange, strange land of endless twilight, with a red sun just hanging on the horizon forever? Well, it would be far from easy, not by a long shot. The huge temperature difference between the hot and cold sides would create these constant, powerful, hurricane-force winds screaming across the Terminator. And those stellar flares, they're still a huge problem, blasting the surface with radiation. Oh, and the only light available for any potential plants would be red and infrared. But here's the thing about life, right? It's creative. It finds a way. And organisms could adapt in some incredible ways. To survive those winds and radiation, Maybe they'd live underground, using the planet's soil, its regolith, as a natural shield. Plant-like life wouldn't be green, no way. It would probably evolve dark pigments, maybe even black or deep purple, designed to soak up every last drop of that red and infrared light. In animals, they might be low to the ground to fight the wind, with eyes that evolved to see heat, to see a world in the infrared that's totally invisible to us. So why is this such a big deal? Because red dwarfs are the most common stars. If even a tiny fraction of their tidally locked planets have a habitable Terminator Zone, this theory doesn't just add a few new places to look for life, it adds billions of potential candidates to our list. What this means is that, all of a sudden, the most common stars in the galaxy are back on the table as prime real estate for life. Planets that astronomers used to just dismiss as too extreme are now some of the most fascinating targets out there. This gives telescopes like the James Webb a whole new, exciting set of worlds to investigate for the chemical signs of life in their atmospheres. And really, as Anna Lobo says, it's all about increasing our odds. The more types of habitable worlds we can imagine and actually model, the better our chances are of finally finding one. We're not just looking for an Earth 2.0 anymore. We're now looking for something entirely new and maybe, just maybe, something far more common. And that leaves us with this one final, really tantalizing thought. Perhaps when we finally find alien life, it won't be basking under a yellow sun like we are. Maybe the answer to that whole rare Earth puzzle is that Earth isn't special because it has life, but because of the kind of life it has. And maybe the most widespread form of life in our galaxy is out there right now, thriving quietly on the edge of darkness in a world of eternal twilight.